This is a presentation for Stoichiometry, which is a PowerPoint that was produced by Sapling, and I'll be talking with you through this PowerPoint going over some examples that are in here. This is a great way to prepare for the test and to be able to do some of the problems in your homework packet. This particular PowerPoint is going over limiting reagents and percent yield. So in this PowerPoint, we'll be looking at how to identify and calculate the amount of limiting reagents and which reagent is in excess, and then also calculating percent yield. So when we have a chemical reaction, we've been learning that not all of the different reactants that we have available in a particular reaction are used. Just like when we did the s'mores lab, for example, there may have been extra marshmallows left over or extra chocolate. So there's times where you have a specific amount of each of the reactants in a chemical equation, but due to the stoichiometric needs of that equation, you will end up only running out of one of them first and the others will be in excess. So those are the calculation types that we'll be looking at today. So your limiting reagent is the reactant that's completely used up when you perform a chemical reaction. So it limits the amount of product that you can make. It's the one that you have available to you in least amount when you look at the stoichiometry of the equation. It's not necessarily what you have least of, just the lower number of grams. It's the one that would produce the lower number of grams of product. And then we have our excess reagent. That's the one that we have some left over, that we didn't end up using all of it. So we'll be looking at calculations involving being able to determine which substance is the limiting reagent, which one is in excess. So in order to determine which one is the limiting reagent, you really have to do two calculations. If we have two reactants, you have to do two separate calculations to figure out the amount of product that each one would make. And then the one that would make the least amount of product is what we call your limiting reagent. And then the other one is in excess. There's some steps here. I'm not going to read through all these word for word. It's really just been what I've been just going over with you, but you could always go back and look at this a little more slowly if you want to pause this so that you can look at the different steps in the calculation. Okay. But I'll be talking through the calculations as I go. Okay. So say we have an example like this. When solid barium reacts with solid sulfur, solid barium sulfide is synthesized. Calculate the number of grams of barium sulfide that will be produced when 10.0 grams of barium and 10.0 grams of sulfur react. So here is the balanced chemical equation for you. We have solid barium is reacting with solid sulfur to produce barium sulfide. And so the question is asking us, if we have 10 grams of each of these, how much product do we make? So you can't answer that by just looking at the equation. You have to do some calculations to figure out how much product you would make. And as I was saying, you have to do two separate calculations in this case because I have two reactants. We look back at the equation here. I have two reactants with two separate amounts. I can only figure out how much product I will make if I do two separate calculations. So what you would do is you would first take the 10 grams of barium and go through the 3 steps that we've been doing lately. These are the same 3 steps that were the focus of your quiz last week, where you're taking the first step to convert grams of barium to moles of barium. Then here we're doing our mole ratio, and then we take that mole ratio to the next step and convert that to grams of barium sulfide. And the answer that you get is 12.3 grams. So that means that based on just looking at the grams of barium, we could only produce 12.3 grams of barium sulfide. Then you have to do a second calculation with the amount of sulfur that you've been given. We're told we have 10 grams of sulfur, so we have to do the same 3 steps. Go to moles, mole ratio, back to grams. And then we could possibly produce 52.8 grams of barium sulfide. The limiting reagent is the one that would produce the least amount. Right? It limits the amount of product that you can make. We would run out of this before we could ever use all of the sulfur available. So by looking at just these 2 numbers, we can decide barium is the limiting reagent and sulfur is present in excess. We have extra, some that we're not using. And as I said, in this case, barium sulfide can only be produced by the least amount of the reactants that we were given. So in this case, we're only going to produce the 12.3 grams. Right, if I go back one slide, these are the 2 different calculations. This is your limiting reagent, so this is what we end up producing. So we know now that we would only produce 12.3 grams of barium sulfide. Well, what we can do with that information now is, what if we want to know how much of the excess reagent is left over? Right? We know that one of them is the limiting reagent. We determined that. And so the other one is present in excess. We have extra. So now we want to calculate, well, how much extra? How much was not used? In order to do that, you take the amount of grams that we know we produced. Right, a couple of slides back, we just calculated the limiting reagent would only produce 12.3 grams. So now if we take that amount and we determine, well, if this is all we produce, then how much sulfur did we use? So we do our conversion to moles, mole ratio, and then we figure out how much sulfur we would have needed for that amount of barium sulfide. So I'm going to go back a couple of slides. So remember in this calculation where if we used all the sulfur, we could possibly produce 52.8 grams. But back here we determined, no, we're only going to produce this amount. Okay. So now we're saying, well, if we only did produce that amount, how much of the sulfur did we end up using for that purpose? And this calculation shows that 2.33 grams of sulfur were used. Well, if we look back at the word problem up here, we had 10 grams of sulfur, but we only used 2.33. Okay? You used all of this because that was our limiting reagent. We don't have any of that left, but we have sulfur there in excess, which means we have extra. And how do you figure out how much extra? Well, I just went over the calculation to figure out how much sulfur would react from knowing that this is how much product we made, and that's 2.33 grams. So if we subtract that from 10, we can figure out that this is how many grams were left over. We didn't end up using them. You had 10 grams of sulfur. We only used 2.33. That means this amount of sulfur is left over. It's in excess. And then the last part of the calculation, kind of the culmination of stoichiometry in this unit, is being able to calculate percent yield. That's a very valuable mathematical amount in chemistry because, as I've explained a few times, we don't have a perfect world in chemistry. You don't get 100% product when you're making something, right? And it's a pretty simple calculation, really. Percent yield is based on how much you actually produced divided by how much you could have produced mathematically. Right? So actual yield is what actually happened in the laboratory, what you actually achieved as a product. Theoretical yield is what we've been calculating mathematically. What would be the ultimate full amount of product if everything went 100% perfectly. So here's an example of a percent yield problem. If we have 18 grams of solid magnesium and it's burned in the presence of excess oxygen to produce solid magnesium oxide. If 27.3 grams of magnesium oxide was produced when this experiment was performed in the lab, what was the percent yield of the experiment? So this is the balanced equation. And it's telling us that we have 18 grams of magnesium and excess oxygen. So basically you're burning a piece of magnesium. And we want to know what the percent yield is. Well, you do one calculation to figure out your theoretical yield. That's really what we've been doing for the past couple of weeks. Mathematically, how much magnesium could be produced. So this is just like the calculations that were on your quiz. I have 18 grams of magnesium. I convert that to moles, do my mole ratio, and now I'm going to convert to grams of magnesium oxide. And so based on 18 grams of magnesium, I could produce 29.8 grams of magnesium oxide. But the problem is saying only 18 grams were produced. I'm sorry, over here, 27.3 grams were produced. So 29.8 is how much could possibly be produced, theoretically, mathematically. However, when the experiment is actually conducted, only 27.3 grams are produced. So it's a pretty easy calculation. You take the amount that was actually produced, divide that by what could have been produced, multiply times 100 to make it a percent, and we get 91.6%. So in this particular experiment, 91.6% of the product was actually formed. Okay. So in this particular presentation, we went over how to identify and calculate limiting and excess reagents, and then lastly to calculate percent yield.